Hi, everybody. Just doing a quick audio check. If someone can use the questions tab just to make sure that you can hear me. I'm going to wait about 5 minutes just to make sure that everyone who wants to attend has a little bit of wiggle room. But yeah, just a quick audio check. All right, everybody. Close enough to 5 minutes after. A few housekeeping things. Yes, everyone will get a copy of the PDFs of the slides that I'll be going over, along with a link to download a recording of it, or at least view the recording of this. My name is Doug Otis. For those hoping to see or listen to Joe Woodward, he's sick today, so I'm stepping in his place. So let's go ahead and get started. This is going over the mechanical updates for 2020 R1. Quick summary. So I work at PADT, Phoenix Analysis and Design Technologies. Founded in 1994 by 4 turbo engineers. We have offices located throughout the Southwest U.S., California, Colorado, New Mexico, Utah, and employees in Texas. We have roughly 85 employees spread across 3 primary business units. The business unit I work for performs or does sales, support, and services for numerical products. As far as the numerical simulation side of the house, we're an Ansys Elite channel partner. We're a distributor for Flownex, which is a 1D thermodynamic solver. And we also partner with other vendors for HPC compute solutions. We provide technical support to all of our customers in the Southwest U.S., in addition to conducting training and mentoring services essentially all over the country. On the services side, we have engineers familiar with all the Ansys products to perform either burst simulation capabilities or complete outsourcing work for companies on essentially anything that Ansys can do. Again, located primarily based in the Southwest U.S., customer focus, working on a real win-win relationship with all of our customers, technically very strong, a lot of real-world experience in all of the physics that Ansys has to offer, and really good at long-term relationships with all of our customers. This slide's a little bit misleading because Ansys Cloud has been out for at least a few revs. And so if you're not aware, there's a product called Ansys Cloud, and it's essentially making HPC or the access to high performance computing resources as easy as it should be. And so it's built off of the Microsoft Azure platform. And it's essentially a one-click burst to the cloud. And so if you don't have the computing resources in-house or you need additional resources due to other constraints, that product is there. And so again, it essentially allows you to run on much more capable, both in terms of number of cores, memory, all that fun stuff, hardware. And so there are evaluations available. Contact us if you're interested in within our sales territory. All right, on to the actual meat of this presentation. So we'll go over what's changed or some highlights over the new features within Mechanical. And so we'll get into the details of each one of these topics. So as far as imported load support, so really this is kind of coupled into how you can mix and match the 2D and 3D body types within Mechanical. And so old revs of Ansys, you were limited to completely 3D or completely 2D. And so if it was 2D, there were restrictions on where the geometry had to be placed, depending on if you were doing an axisymmetric plane stress, plane strain. And so now at 2020 R1, you can mix and match this generalized axisymmetric behavior to have 2D representations of the structure in addition to having 3D representations. And so as we do that, there's an expanded support to basically apply pressure loads to a 2D shell element. And so takeaway here is that this is a mixed resolution geometry. There's a part that is set to be a plane stress shell, meaning spatially it's just a line. And so with that line, we can apply a imported pressure profile to it. And so that's another big thing, is just the ability to mix and match this topology or this mixed resolution in a single simulation. In addition to that, there's been a lot of enhancements to line bodies within Mechanical. And so the first one is this treatment option. And so this treatment is essentially a way for you to toggle whether or not something is meshed and solved for, or if it's just there as a construction geometry. And so this was previously available to solids and surfaces, and so making everything more consistent, this now treatment option is available for line bodies. So the big benefit for this is, let's say you wanted to create your own custom path objects in your construction geometry. And so rather than having to imprint your geometry everywhere that you wanted to have a line and then resolve the mesh along that line, Now you can just import a line, specify that it is a construction body, it is not meshed, and then you can use that for scoping for a path operation. And so that way you can mix and match it and have all these complicated lines and shapes without having to actually resolve the mesh. In the 2D world, there's going to be a lot of work as far as visualizing kind of FEA behavior, and so and we'll get into that. We'll get into some additional stuff later on. But first up is visualizing contact normals, and so for those that do a lot of contact modeling, the normal of a contact element is inherited from the body, and so typically the contact points outwards. And so depending on what you're simulating, how clean the geometry is, there may be cases where you need to flip or somehow visualize which direction your contacts are looking to contact the other side of the interface. And so the ability to visualize that in 2020 R1 and also change, so flip whether or not, essentially flip the normals on the contact elements. So going back to line bodies, at previous revs of Mechanical, if you wanted to create a line body, you had to do that within either Design Modeler or SpaceClaim. And so SpaceClaim had some nice tools for extracting cross sections and passing those on to Mechanical. In Mechanical, you can now define your own cross sections without those being passed from an upstream process like SpaceClaim or Design Modeler. And so a couple benefits to this. And so if you've ever used the beam tool, in order to display those results requires that you have kind of these standard cross sections. And so when you do an extract operation within SpaceClaim, that's passed over as a user integrated, regardless of if it's a circular cross section or any other standard. So if you want to use the beam tool, I don't know many people that still do because there's a better way to view beam results, but if you're a fan, you can create these standardized cross sections within Mechanical without ever having created these within Design Modeler or SpaceClaim, and then assign them to line bodies within Mechanical. All right, so jumping into Workbench posting graphics, I think we're going to have a couple redos of this. So apparently I get paid by the slide. So quick rehash over the contact normals, looking at a 2D contact representation and the ability to toggle those on, off, or reverse them. All right, so going into line body treatment. So one thing that if you're doing a lot of thermal network, so when you import a line body, if you're doing a thermal analysis, you can specify that it is a fluid link, or basically capture thermal advection through these fluid 116s. So what we can now do is visualize where the node or where the vertex of a fluid element is attaching to a surface. So if you're doing 2D thermal simulations of an entire turbine, you want to make sure that where the fluid elements are located are properly connecting to your actual turbine structure. And so the ability to now display these connections and give you the ability to verify that everything is properly connected. So in previous revs, you were limited to 6 section planes. As soon as you created 6, you would see that the new plane button would be grayed out. You couldn't create any more. Now you can create all the section planes that you want. The only limitation is you can only have 6 of them on at any given time. So as far as 2020 R1, remember at, what is it, 2019 R2, we switched to the ribbon interface. So going from the old I guess I can't call it old, but the standard mechanical version to a much more ribbon and organized interface that we have now. That change exposed a whole bunch of other features and scripting opportunities as far as that interface is concerned. And so in addition to some redo of the API and the journaling and scripting, there's been some additional enhancements to how you can extract data using ACT. And so part of that is using plot data and the ability to just more cleanly get out data from your simulation. So as you're going through and defining your own beam cross-section, you have the ability to actually plot what that cross-section looks like on the ribbon. And so as you go through and edit the values that you see on the left, it'll properly update on the right. So Smart Select is essentially, if you're a Space Claim fan of how selection works there, it kind of tries to guess what you're trying to select based on what you're hovering over. That is now the standard within Mechanical. So as you go through and move your mouse around, if you're over a face, it'll allow you to pick that face. If you're over an edge, it'll allow you to pick that edge. If you triple click, just like in Space Claim, it selects the body. And so think of this as kind of a more uniform or consistent mouse clicking experience between Space Claim and Mechanical. And so if you want to turn that off and go back to the very kind of regimented topology selection method, you can just uncheck the Smart Select above the graphics window. So there's been a lot of work going on into the solution combinations. And so previous revs have exposed the ability to combine some linear dynamic results with static and transient results. And so at this rev, there's more combination types. And so whether we're looking at a transient thermal, transient structural, and we're trying to essentially find the maximum value over all the environments that we're looking at or anything like that. So just a lot more control and features over how we want to combine the environments that we're referencing in our solution combination. And so we should see some more enhancements added to this as we move forward in the 2020 rev cycle. But right now, these are the kind of 3 or 4 combination methods that we have available right now. So a few revs ago, Ansys introduced the kind of meshless reinforcement elements. And so those are creatable through APDL. And so it uses some Mesh 200 elements to essentially smear with some reinforcement elements. And it was originally developed for tire simulations. And so if you, the only issue is you could script this in within Mechanical. It was just very difficult to post-process results on the reinforcement elements. And so this has now been fixed. We can post-process results on those reinforcement elements by using some solution options to look at result file items. And so if you've never done this, if you click on Solution and click on the Worksheet button, there's a lot of different ways that you can post-process your data beyond the standard buttons that you'll see on the Solution toolbar. And so if you're interested in a lot of digging into either specific element results or scoping results by element ID, this worksheet view on the solution branch gives you a lot of control. And so what we're showing here is if we click on the solution, click on worksheet, we can scroll down and rather than looking at our results on a body by body basis, we can have it show us all the different element types that are in there. And so if we click on that radio button, we can then see that we can look at results scoped to our reinforcement elements. And so the ability to post-process and look at the results without having to go to APDL or anywhere else, that is now directly available. So talking about the mechanical, essentially framework. So we've replaced the ACT console with this scripting interface. And so it kind of maximizes the real estate that you have available. It gives you access to scripting, editing, and journaling as you go through and build this up, in addition to integrating with the button editor. And so, again, this is all kind of a slow progression from the switch to the ribbon interface. Gives us a lot of additional tools for how we journal, how we script, and how we customize the toolbar. So there's only a picture here of a turbine, but there have been a lot of thermomechanical fatigue material models that have either been added or enhanced within the Workbench interface. And so this applies to turbo machinery, combustors, all that fun stuff, and also on the lovely, and also on the electronics reliability front. And so if you're in either one of those, or you're looking at thermomechanical fatigue modeling, a lot has been done and added functionality-wise within 2020 R1. So external model is the utility that allows you to import data from other tools. If you have customers or other colleagues that are using Abacus, Nastran, or giving you APDL models through a CDB output, we have the ability to read those in, and that way you can work with essentially a mesh-only model. And so depending on what version you're using, there were limited element types, keywords, kind of you name it, that were supported. So if you're using an older version of Ansys and you're working with other model types like Abacus, Nastran, I'd highly recommend going to the latest version, because every version, new elements, new keywords, new features are supported as far as importing those models and creating the Ansys equivalent of those. So first thing is nonlinear springs from Abacus using the Spring 2 table. Being able to import the theta for element orientations on a Nastran shell element. The ability to not only import single parts, but also now import assemblies from Abacus and understand all of the different contact interference and clearance cards for any interactions between your bodies. So again, these are just node and element, finite element only models that we are able to import and then run a simulation within Ansys. Another thing we can do, since we can now define cross sections within mechanical without needing an upstream geometry session, we can now import beam elements without any cross-section assignments, and then we can just overwrite or reassign them within mechanical. And so import beam elements without cross-sections, and then you just make sure you use the cross-section creation branch, and then you go back and assign them. So all of these features, the ability to assign cross-sections to beam elements, the ability to read and node an element only models, and just this kind of trying to make mechanical, for better or worse, more mechanical APDL-like, where it's essentially a one-stop shop. We can now launch mechanical in a standalone mode, and then we can drag and drop models directly into the mechanical window in order to start building up our model. And so